were in Ohio for a MeasureQuick training, and it was like drinking from a fire hydrant, HVAC masterclass. And one of the things, like one of the biggest takeaways that I had really energized coming back to our group and install is there are standards to everything. You know, a lot of people have done a lot of work over the years to establish design specifications, and this stuff works. We know that it works, and physics, science, there are laws of physics, laws of science, how much an actual pound of air, like air does have weight to it, how much an actual pound of air weight or is, how much space that it occupies is 13 cubic feet. The density of air at different temperatures, the way that it behaves, refrigeration, all of it. And even it was presented by MeasureQuick, and so obviously we were in the MeasureQuick app, and it's just bananas the amount of science and math that application does, and it all fits in line with what Brian's been saying regarding probe deployment and being able to solve problems. One of the statistics that they threw up, 7 to 10 out of 10 homes. It was in the Houston area that they did this survey, but 7 to 10 out of 10 homes have issues with the HVAC system. It's either not operating properly, the equipment's not operating properly. Overcharge is a huge issue. The system actually being overcharged. Why would a system be overcharged? Why would that be a significant, or why do you suppose that is an issue, a system being overcharged?
Shady text.
Huh?
Shady text.
Just add a pound, not necessarily knowing and understanding. But that's all our customers' comfort level, and then that's also things that we can fix. We can make adjustments. We can do little fixes, we can do big fixes. So yeah, there's a ton there. It got me into kind of a different mindset, and kind of like a goal setting mindset, again, that totally matches everything that we continue to do, providing simply great service. I want you guys to be considering some goals in this coming year, both professionally and personally, and I am going to make you share with the group for accountability's sake and then for support's sake, because we're crew, we're homies, we're squad, we celebrate what we've done. Growth is a good thing. One of my goals is that continued development of this department, and it's right in line with what Brian does. And I just became convinced of it while we were up in Ohio on that training. And is to make sure that everyone has an understanding, a full understanding of what's going on as technicians. I continue to grow, you guys know that, in my technical knowledge, my technical base. But one of the things that I think is going to help the most is using the MeasureQuick app, and this isn't me just fangirling, it's maybe a little bit, but using the MeasureQuick app, because it is so helpful in deploying all of our probes, every single stop that we make, deploying every single probe. And when I say every single probe, I want to just kind of start with, what do you think I mean when I say every single probe?
Every single probe.
That's true. That's good.
That's solid.
Elliot,
I also thought that.
Elliot threw up a number. Elliot threw up 9. What would those 9 probes be? Not Elliot.
Static pressure.
Static pressure.
That's 2.
Okay.
Suction. Actual climate. Temperature climate.
Mm-hmm.
Pressure.
Temps splits.
Mm-hmm.
Okay. Temps splits. What did the last? There's multimeter. Yeah, you check McFurter's voltage.
That's not a pro.
No.
That's good, that's good.
That's good.
9 probes, that's good.
But it's not the one we're looking for. We need 3 more.
No, it's not
What
bad.
would you
Throw your meters away today.
All you have, hand manometer. No, you try.
Already said the
What
pressure.
are we missing, Elliot?
Yeah, we need.
He already said the pressure.
Oh, he did say the pressure? But there's one more.
There's temperature,
Oh, boy.
probably manometers, anemometer.
These are all great tools for it.
Yeah.
Huh?
That was good.
Thermometer.
He guessed it.
What was it?
Yeah, that's a good thing.
What's the last one, Elliot?
Outdoor air temperature sensor.
Outdoor air temperatures. Not
What do you
bad,
mean,
not bad.
your psychrometer?
No. Or get it just to get a cheap little thermometer and put it
I'll just
outside.
use this.
See what the
Deploying probes,
Not, yeah, I know. Not using the weather app though, because conditions change whether we're in the sun or in the shade.
and there
Yeah.
are, yep, and there are some specifics to how your condenser is working and operating. And so yes, you can pencil in the outdoor ambient temperature, but it is really helpful to have that measurement right at the condenser. So deploying all of those probes, we are really, really good we're very good mechanically. And what I want to get us to, that was one thing from that training. Congratulations, you fixed the equipment, you got the system back up and running. We are super, super good at that. But we have all of these tools and we have that app that can give us a picture into other things that are going on. And it's kind of like looking up and becoming masters of the obvious. Airflow is a huge issue in our market. A huge issue. There are a lot of trash homes all throughout the United States of America, but particularly in the Southeast, we got some real trashy boys. And little adjustments that we can make for our clients' comfort and for our ticket sizes. We are going to do some goal setting when it comes to your ticket sizes, when it comes to the amount of revenue that you are generating, when it comes to the income that you are making. There is a lot of potential, again, for client solution, client comfort, revenue generated, and your income. And it all can, but none of this is new. None of this is like, oh my gosh, we're actually going to do everything totally opposite. These are things that you know, and we're just going to be zooming in and making sure that everybody knows like the fundamentals, the basics, and then we get away from just servicing the machine and looking at the system in its entirety. And one of the biggest helps in all of that, Brian's mentioned it, and Bert is going to help us out today on that, is our static pressures. Static pressures. We're going to start taking those readings because it gives us insight into what's potentially going on. Positive pressure, negative pressure, do we have obstructions? And this is going to be very, very helpful. We're potentially leaving a lot on the table. And I wanted to give you guys quickly, lastly, some statistics. A technician, I think he was in New York, from June to August, whatever. His total sales were $288,000. His average ticket size was $2,800. It's New York. So those margins are gigantic. 288K. Average ticket was $2,800. Okay. So those are averages. And then he started using MeasureQuick. And all he was doing was deploying 9, 10 probes, deploying 9 or 10 probes, and cruising through. There's guided workflows in there, some hand holding. This is a lot of stuff that you guys know. I don't know anything about this technician, but this was just a case study that they did. He used MeasureQuick, same time period, June through August of the next year. And his total sales were $465,000. Average ticket was $4,600.
What the?
Yeah.
I mean,
Again, like
How
these.
New York?
Again, it's New York, right? So everything's outrageous, everything's expensive. It's different, but it's basically
It's doubles. the point.
basically a 50% increase.
When is he starting?
I'm sorry?
When is he starting?
Oh, yeah. He's actually going to be your new boss. All he was doing was getting the data. Those needles, those gauges, you swipe through and you can get different reports, readouts, whatever. Just using the app, he was able to double his tickets. Double it. Guess what else he did? He I don't know that he doubled. His pay wasn't included, but I would anticipate, his bosses were slapping him on the back. And so that's just getting a picture of what's going on. There's an indication we have an airflow issue. We can know all of that because this is all standardized. The data doesn't lie. And that's rather than just like jumping into the attic and like looking for issues or here and trying to find the issue, like our pressures, our temperatures, our gauges, all of our readings can tell us where to look. So it's knowing how the system works and operates mechanically, and then airflow design, and then becoming masters of the obvious. Is something disconnected? Is the blower dirty? Is the coil impacted? Do we have weird strips on the top of the evaporator coil where air is just rushing through, where it's not slowed down and we don't have dehumidification because of the dew point on the evaporator coil? We're missing so much, but we're going to make space and we're going to make time to service our customers, get them comfortable, generate some revenue, and stack some bread in our paychecks. But again, a lot of that is going to, we're going to be finding airflow issues with our static pressures. So I wanted to make sure that Bert had space today to kind of go over that.
As you guys have been hearing from Brian about deploying all the probes, it doesn't make sense for us to deploy all the probes if we continue to provide the same service that we've been providing for the last 15 years at Kalos, right? We can keep doing the same thing we've been doing for the last 15 years, which works. And we don't need all the probes for that. So Brian's conversation is that he wants to see growth in our company. We want to see that. And we're all very excited and energized. And so you keep hearing us coming up here and getting excited, talking about bigger conversations and looking at whole home envelope stuff. Because we want to aim for something that we haven't really tried for as a company before, which is becoming technicians that are better at solving more than just the capacitor and drain line. So I just wanted to repeat that again, that we're not trying to add more work to your current process. We're trying to change our current process. And part of making that possible and remaining really good technicians, actually doing the job right, is a better understanding of the whole system, a better understanding of ductwork, airflow, and the needs of the whole home. And so goals in 2025 are going to be a lot of growth for us as a company in areas that we normally don't think about maybe as much or use. Maybe we think about it, but we're not sure how to use it. And so whole home, airflow, things that we can improve on the system that are different than just the capacitor drain line. So static pressure. I want to talk a little bit about that. Anybody used a static pressure and found it helpful on a service call, static manometer? I want to hear a story. Elliot, keep it short.
For airflow, or I did gas pressure recently.
Gas pressure? Okay, good.
Yeah.
How did it help?
We're in furnace season. I made sure that there was in the gas pressure and there was outlet gas pressure at the proper rating for the valve.
Okay, nice. If you think you have a failed valve and you don't have the right inlet gas pressure, it's not your valve. Excellent. Anybody for airflow?
Failed CXV, multiple times, but it, found like it was one of the dampers.
Mhm.
It wasn't working properly, so
Restricting. Then you use the probe help you find that?
yeah, but
How?
just put it on the top and see that it was like way too high, it was too much static.
Mm.
So I'm gonna check.
Nice. I went out to a job, was the third person out there. We were having a problem trying to figure out what the heck was going on with airflow under this trailer. And once I checked the supply static, it was outrageously high, and the return static was low. So I knew we had a blockage on our supply, and that was preventing all the airflow from really moving. Couldn't even suck on the return because it wasn't pushing into the supply. And that motivated me to get into the attic, dig, and start pushing, connecting, everything sealed. I can't see it, but I took my probe down under there, which was this one, the portable one, which was kind of nice. But I didn't have this one on me, or I would have, so I didn't have to use my phone. But going through there and sticking it in, finding out which direction from the branch that it had really high pressure. So from my branch off one side, it had really high static pressure, and the other side I didn't. So I knew that my blockage was in that direction. And it was just one of the 10 inches. The internal had broken and was pulled back a lot, and it's being pretty tricky to find, but the static probe helped me with that. So that's for diagnostic, finding problems. But what about just telling us in general how a system works? What is a static pressure reading at a like fundamental level? What is a static? What is the manometer reading?
What'd you say, Luis?
You want the meaning of it, or like what's that?
Yeah, sure. What's the purpose of this tool? What does it do?
Well, I'll give you simple terms. It
Okay.
measures how much pressure you have in the duct.
Okay, that's all I wanted to hear. Simple terms. It measures how much pressure you have in the duct. So where else do we measure pressure to tell us what's going on with our unit?
Refrigerant.
Yeah. So if you walk up and your suction pressure is 120, you know that your system is running. And it's probably pretty close to where it's supposed to be, right?
Yeah.
If your head pressure is 600,
You're out of heaven.
that's pretty bad, right?
Turn off the brake.
Let's say that the system has no safety switch on the high pressure, and it's running at 600 PSI. What are we worried about?
Explosions.
Explosions. We're worried that it's going to blow out. It could create holes and actually dump the refrigerant. What about if the copper is really good and it's just going to run at 600 for the next compressor overheating and failing? Yeah. So our static pressure is doing the same thing for us. It's telling us what's going on inside of our ductwork. And so if we have really high static pressure, our compressor, or our blower is under a lot of strain, and we're burning up blowers. We're hurting our system with our high static pressure. Is a compressor running at 600 PSI an efficient system?
No.
No. If our compressor is running at 600 PSI, our customer is paying extra money every time that thing turns on. Strain on their unit, extra money. It's pushing against a lot of resistance. So we know that we're already used to using pressure every day and relying on it for our refrigerant. Now we need to get used to using static pressure for our airflow and what it tells us. It's your first week on the job. You just learned how to hook up gauges. Your trainer decides to sit in the van, tells you go check pressures and what's going on. You go out there, you hook up, and you're looking at these pressures, and you're not really sure if there's anything here to talk about. Why? Because you don't have any reps on it. You don't have anything else to compare it to. Trying to remember what you heard in a class a long time ago from Bert about static pressure. Well, one of the reasons that we're gonna deploy probes every time and take a screenshot and upload it as our readings is that we are gonna get reps on what normal looks like and when things are starting to get off. And we're gonna get experience. You can learn things in a class that help you, but experience also really teaches you a lot. When you see something that's really out of balance, this isn't normal. I know I can improve this. You open the return and it's got this tube going up instead of a direct return box, it's just a tube going up, and you know, okay, my high static that I measured above my filter is because I don't have a return box here. We could actually really improve the efficiency of the system, the blower's life. Every time they turn on the unit, they're using less power, it's making less noise, but building out a box in the bottom of this unit. And so I want you guys to start practicing using your manometer, and I'm just gonna start out with some basics. We do have a lot of videos, including 3D videos. MeasureQuick also has some helpful videos on how to use this with their app. But when you're testing static pressure, total external static, it is a measurement of how much strain, pressure strain, is the airflow experiencing on this unit. So when the blower's running, it's pulling suction, it's pulling air in, and there's a suction strain. It's sucking on all the surfaces of the side of the airflow, and it's pulling. And so that's a static measurement. It's a negative measurement, but it's still resistance, still a pressure measurement. And then as it goes through and pushes, we're pushing against the duct flow. Again, another pressure reading, positive pressure. When you're taking total, if we have minus 0.2 and plus 0.2, then we have 0.4 static total. We ignore that one says minus and one says plus, we just throw the numbers together. So total static measurement is how much strain is my blower under when it's hooked up to everything. Things that your blower experiences as strain is your ductwork, but also your filter. So you need to measure how much pressure is my filter producing. So if your filter's right here, then you want to put your probe on top of that. That way you have the full suction of that blower that's pulling against the filter. If you put it below there, then you don't see how much pressure the filter is creating. You just see the ductwork past that point.
You can see how much.
And if you do both, you can see how much exactly the number that your filter is causing by itself. Yeah, so if I had 0.1 here, 0.2 here, I know 0.1 of my static pressure resistance is caused by my filter. It's usually higher, it's much higher than that actually. So, not much higher, but it is higher. That can tell us the total static of our return when we take it above wherever our filter is. If our filter's in a return, then you can just put it anywhere in here, right? And it's back there in the return. If it's a media filter, then we need to go above it as well. And then the supply is a little easier because there's nothing past this but ductwork, and so we can just put it right on top of the unit. That will give us our total static pressure. That total static pressure is plugged into MeasureQuick, and then it will pump out the estimated airflow that unit is experiencing based on that static pressure. And so one of the things you'll have to do is enter the tonnage size into your system and its SEER rating. So it has like a, not the ID, but the, what's the other one called? The what?
Oh,
No, it's system ID and then system profile, thank you. System profile. And so you enter it in your tonnage and the efficiency. And then if you have active static probes in there, taking the total, it'll tell you what airflow that this unit is experiencing. Now, if you have a dirty coil in here or a dirty blower wheel, those numbers aren't going to be accurate because your probes are not reading that. They're in here. And so this is in between that section. The probes don't know that those things are dirty, right? And so if they're dirty, let's fix the problem. Then we can take our measurements and see what the system is working with design. So one thing I just wanted to do today is tell you that the reason that static pressure hasn't been super useful and that we haven't been using it much is because we are just trying to get the system back up and running. And we're not looking at the whole home comfort and its implications. And the other thing is because we don't have the reps to know what to do with it when we find issues. So if we're putting the probes in every time and we're talking about what we're finding, we're looking at videos, we're listening to some podcasts, we're going through the workflow on MeasureQuick, the suggestions they make on some of the stuff that you find there, then we're gonna start getting ideas for, hey, actually, now that I look at this, this is a pretty poor design. We could really improve this. You have a 18 by 18 return grill in your living room that has a filter in it. That's a major restriction for airflow. Not only does it have to go through 18 by 18, but there's a filter right there. I could put a media filter in the downflow and really improve the static pressure of this unit. And so let's put the probes in. Let's start actually measuring static pressure and one, getting really comfortable with using it, knowing how to use it. Look up some videos if you need to. And as the new year comes in, we're gonna start probing all of our probes and using MeasureQuick as just a baseline for us to see where there's flags, and then their workflow also with communicating with the customer or suggestions that they make for us to, hey, dive into this on the workflow. So this is a few guys were sent up on both teams to the MeasureQuick conference because Brian was really excited about what MeasureQuick was doing recently. And some of the changes that they were making, and that they were easier to work with. Some of the conflict was resolved. And so this came from Brian, paid to send people up for some education. That'll continue. I'm sure there'll be more education coming down the pipeline. We're not going to be able to avoid this, but what Dre said is really important. We don't want to avoid this. If this works, and we are increasing our ticket sizes because we're looking at more than just the capacitor, we're going to get paid a lot more as technicians. And I think that's a pretty good goal to have in 2025. Is there a lot more that I actually could get paid in 2025? And there's two ways of doing this. You can sell the customer stuff they don't need and then never go back. You can maybe trick a customer into thinking that they need something they don't, scare them. Or you can become really good technically at your job and realize that those facts are true 7 to, I don't know why I said 7 to 10 homes, but at least 7 out of 10 homes, with how cheap things are built, could use major improvement on the whole envelope, duct design, things that aren't exactly whether the system's turning on or turning off. And we can get better at actually knowing that and knowing what to look for and knowing what the fixes are. So that's what's coming. Employing static probes is a big part of that. I want you to think about it like you think about just taking pressure on your refrigerant. If I get the reps on this, if I start using this, will it help tell me a little bit more about this unit? And then, is there a way I can use that to find a problem? Maybe increase the return size at Richard's house. Maybe repair the ductwork that was broken. Maybe quote a damper that is getting stuck. And we're not having to come back out to this house 3 or 4 times and losing money in the process. And so thinking about those things, using a little bit more tools, I think it's going to be really good growth that we have ahead of us. More detail on this, and as far as class comes, will come later. I just wanted to sell you guys on that we're going to be using it. Let's start using it to get reps.
So I'm still trying to understand the like where you should be putting the static pressure probes. So you were saying like you can put one above.
Yeah, above your unit in return, but in the return above the filter. So I will often take this out, stick this in like this on top of the filter, and then take any gaps that I've created, shut.
So does whatever angle, you know, have like the arrow, if you don't have it in the direction of the arrow, does it affect the efficiency or the, like?
Not much. Honestly, the kind of airflow that we deal with in residential, it doesn't really affect much if you turn it curl. You could do this as part of your reps exercise. Take the arrow, put it this way, put it this way, and let it sit after you've changed it and just look at the difference. If you're not really noticing a difference, then you probably don't have to worry about that. If you have it sideways, right in a stream, then maybe, but like up versus down, probably not gonna make any difference. See how I have this in here, I just have it on the corner, there's a little bit of whistling air, I can cover that with some tape, but I'm above the filter.
So Bert, question, so does the pressure change depending how far the filter is, like a return grill, rather than right at the unit?
So if you have it in a return grill and you measure it here or here, the pressure's gonna be the same.
No, what I mean is the pressure's gonna change
It's not.
in the two different applications.
Oh,
Like the 18 by 18 in the living room as opposed
Yeah,
to
yeah.
a media filter.
Yeah.
yeah, so if you had a 20 by 20 in the living room
Yeah.
or a 20 by 20 in the unit, you probably have a very different static pressure, yeah.
Which one is better for you?
It depends on grill design, maybe the box right behind here, but usually the one in the unit is the most restrictive.
Right.
Now,
So they
as soon
recommend
as
a
this
media
starts
filter.
getting smaller than the unit, like if this was 18 by 18 and our unit could fit a 20 by 20, there'd be a huge improvement to have it in the unit. But if they were technically the same filter size, it's almost always more restrictive in our unit than there. Because if you think about it, right here we have a whole space of the home.
Right.
You're kind of squeezed into every angle. Right here, our airflow is very specific. There's no, it's not coming from any other direction, it's just blasting straight through the filter restriction. There's also gonna be more turbulence inside the ductwork. So this, like here, is part of the ductwork.
So most of the time, are you concerned with like the static pressure just after the filter?
So,
And what's
yeah,
the
if you're
reason for
taking the
that?
measurement and you're wondering what kind of strain is my unit under, what is my blower dealing with, it's after the filter. If you're looking for a problem, like I have really high static here. Do I have really high static here? Do I have really high static here? If you still have really high static here, it's not the filter causing it. It's something back that way. So that's where you would start. If you're chasing problems, then you're not just checking total external static.
I see
So
what,
think-
because you're trying
yeah.
to zone in on the issue, so
Yeah.
you're talking more about like in connection to the blower.
Yeah, so right now,
Okay.
I want you guys measuring total external static and getting used to seeing those numbers, what looks normal, enter them into MeasureQuick. If you have something that MeasureQuick can read, that's nice. If not, you can just punch it in. And as you get used to doing that and getting more reps, there'll be future training on this. But I just want to tell you guys, start putting these in. We're gonna be using them more, and I think you'll start finding things right away that you can think about quoting or process. It'll be good.
What's a high static pressure with something?
So, 0.5 is like a good normal. 0.5, you hook up to ductwork.
Total?
Yeah, total. 0.5 is like a good normal. As soon as you get higher than 0.5, you're starting to strain. On the data tag, they tell you what they tested it with. So this one was tested at 0.5. A lot of them say 0.25 that they were tested from the factory. And so all of its matrix, its efficiencies, everything's built off of nothing higher than 0.5.
Infinities are a little weird.
Yeah, infinities can be weird because they have such a fluctuation of airflow. So you would have to test it at full airflow to know what your static pressure was. Or you could just ask it to do an airflow test and it'll tell you itself.
So does it matter the difference, or say this is a -1 and that's a +3?
Yeah,
So it just
it
total.
does matter.
Okay.
So total is the strain your blower's under, but when they are really different, when you have like 0.43 here and almost nothing here,
Right.
we're really squeezing our return, and that's why we don't have high pressure here, because we don't actually have a lot of airflow pushing up.
And that's gonna be
Yeah.
a dirty evac coil.
So then you know that like, what you want to see is them pretty balanced. That one's not gonna be a dirty evac, no. What you want to see is them pretty balanced, where you have pretty
If you measured like above the coil,
I'm sorry.
Yeah.
You're measuring like the sucking.
It would actually
Yeah, it's the
it'd be the
blower.
opposite.
So it
Yeah,
depends on
it's
where
the
your
blower.
thing is, because you can measure static above the evaporator coil too if you drilled a hole.
Mhm.
That would let you see that you have a
Yeah.
dirty evaporator
Yeah.
coil.
It's the opposite. No matter what.
Right.
If we drill a hole very carefully.
You can use a cycle.
Don't drill into Pam's
The UV light.
unit.
You guys are asking great questions, and I
Yeah.
see like your wheels spinning. And that is like a really, these two quotes, you can't manage what you don't measure, right? Why does that blower motor keep failing? Blower motors shouldn't be failing. You can't manage what you don't measure. And without data, why does this blower motor keep failing? Or why are we having these issues? Without data, you're just another person with an opinion. Like, man, we could do this. Like, we can try this, right? We try and steer you guys away from that in the summer. But with that data, with those numbers, and as you learn what they mean, like, you can get in there with an expert opinion. Like, Carrier designs, Lennox, all the different manufacturers, they know that customers are going to be putting a filter in there. But what they can't prevent is the customer putting in some crazy filter and then leaving it in.
allergy filter.
Some have a like surgery room filter, and then they have 37 cats and they never change the filter, right? So like becoming masters of the obvious, but taking those measurements and getting our data means that blower motors, number one, aren't failing, right? They're not failing because they're under so much strain, or potentially wrecking a compressor, same thing, just those constant, if something slips and it gets to those high pressures, energy usage, right? Can we like confidently tell a customer that if their system is running more efficiently, that their bills are gonna be lower? Yes, we can. We can. We can take amp draws and we can test in, test out, right? If we make some adjustments, we delete that filter, put in just a MERV 8 or whatever the thing is, or deal with the obstruction, clean the blower wheel, clean the evaporator coil, and then we see amp draws are lower, like what is their energy bill, right? So these are all legit, real, practical things for our customers, and all we have to do is deploy a couple probes and get some readings. It's super simple. And it doesn't take that much time to hook everything up. Start inside, work your way around. Masters of the obvious, just getting eyes on things. That door is closed. That door is not closed, right?
I did want to say that this guy, he deployed probes, but the customer didn't pay him for the extra probes. They paid him for the solutions that he brought to the table because of what he found. So what he changed as a technician was finding more, right? But what the customer's experience changed also, but they had another conversation. I found more, I dug deeper, right? And so right now we're talking about deploying probes, get used to this, everybody on the same page. We're gonna be taking MeasureQuick screenshots and putting them in as our readings. This is gonna be the new pattern. We want to prepare you guys technically for what there will also be training on and discussion between all of us. We're gonna find out what works, what actually helps the customer, how to have these conversations. There will be training on how to take the crazy static pressure measurement I'm reading and turn it into a conversation that turns into a higher ticket. So I want you to know that this is gonna be in stages, but let's start out with what we know as technicians. Right, and expanding our knowledge and thinking about that. Let's do some technical practice. Let's get reps on this and be thinking about how can I turn this into something that helps the customer that I can get paid for. But know that coming in our future meetings, there's going to be more conversation about how to turn what you find into dollars as well. So I'm not going to leave you hanging on that.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.